Welcome to Emerging Languages Camp 2010. Thyrd by Phil Mercurio.
Good morning. Today I'm going to present Thyrd, an experimental language I developed as proof of concept and as a research tool. I also just realized this is the third talk. I don't know if you guys planned it that way. Nice. The motivation is a minimalist visual language, keep it as simple as possible. Programming as much as possible via direct manipulation, so work well in a low typing environment like a tablet or pen-based machine. Visualization of code execution as part of debugging. The notion of code behind the interface. I won't be able to talk too much about this, unfortunately, more than on paper. But that's the notion that given a user interface element, you can navigate from there to where the code that controls that element is. And also self-modifying or reflective visual language, specifically as far as that might be interesting in implementing machine learning. And I'll talk about that briefly at the end. So Thyrd is a stack-based interpreted language. It's functional, concurrent, visual, and reflective. I'll talk today about prior work a little bit. Then I'll present the key concepts in the language. I'll concentrate on 4 example programs, and then I'll talk about future work a little bit. Down the bottom is a link to a paper that corresponds to this that has whatever I can go around talking about today. The user interface in Thyrd was inspired by Smalltalk, just like everybody else, and Self, both very minimalist systems, also systems demonstrating inspecting and modifying code within the interface. And down here, Boxer, which was developed in the early 80s at UC Berkeley. Somebody else will here. It demonstrated hyperprogramming of code as hypertext in nested boxes, and also the notion of code behind the interface. That's really where I got that from. Exceptionally. From the spreadsheet, I stole the notion of the grid as both user interface and data type. You can also argue that Excel is the most popular programming language currently in use by an order of magnitude. Other systems that stretch the spreadsheet paradigm one way or another: ThingLab, Spreadsheet 2000, Forms 3, WizCell, and Subtext. Subtext will be presented here today, tomorrow. From the language point of view, Thyrd is most like fourth. You just got it. Okay, you just got it. It's a very minimal language. It's also like Joy, which is the functional cousin of Fourth, adds functional programming to the Fourth model. And Bifunge, and other two-dimensional programming languages. Thyrd is essentially a funge, but hopefully it's a little bit more readable. The fundamental unit in Thyrd is the cell. A cell may or may not be located in a grid. It may have neighbors. A cell can either be atomic, in which case it has a single textual value. Everything in Thyrd is a string. But cells do have types associated with them. The types are used to control how the value is interacted with and displayed. It doesn't constrain the value anymore. Everything is a string. Non-atomic cells contain a grid of subcells. The grid expands as needed. Not all locations have to be filled. This is two-dimensional, but conceptually could be extended to more dimensions. The entire space of cells is called Thyrd space, and there's one root cell at the top, which is referred to as slash. Everything else is contained under that cell. This is how Thyrd displays a grid as a table by default. You can see here what looks like a Unix path name. This is the path to this cell from the root of Thyrd space. Each cell also has a unique ID, and either one can be used to refer to the cell. This is zoomed in on a single cell. You can select the type of the cell from a drop-down menu. When you view a cell in the grid, they're all viewed as text. All types are viewed as text, except for opcodes, or instructions in the language, which are viewed as icons. But if you zoom into them, even an opcode is just text. It's just text that's been marked as executable. Some types, like integers and reals, can take parameters, specifying in this case the low, high, and step value. Or if you have a choice of strings, you can specify a list of values for that. Now when I turn on the user interface panels, you can see that a string is edited as text, the number is edited using the spin box, and the choice becomes a drop-down list. These are the default panels. You can build custom panels, and by inspecting the panels, you can find out the code underneath, and that's the code behind the interface ID. Within a grid, you can specify a subcell by its coordinates. The coordinates begin with 0, have the y-axis horizontal and the j-axis vertical in this display. So that cell outlined in green here, that contains the word 2, can be indexed as 2, 1. If the j value is not specified, it defaults to 1 unless I is 0. So the same value could be indexed as simply 2. This mechanism of defaulting the values means that indices means that you can expand this beyond 2 dimensions. So I haven't done that yet. The cells that are I equals 0 or j equals 0 are called the frame cells. In this particular example, cell 0, 0 doesn't exist. The rest of the cells are the content cells. If the frame cells contain text, if they exist and contain text, they can be used to index into the content cells. So this same cell can be indexed as beta English or simply as beta. This addressing scheme makes a third grid essentially a general data type, a union of a variable if it's just a single value. A list of values can be indexed numerically. Add the I frame in and you get a dictionary. Add the J frame in, you get a relation or table. And hierarchy can be represented using containment. You can also get from one cell to another cell using relative paths. Starting out at this cell here, the path dot dot refers to the containing grid cell. Plus 1 plus 0 refers to the cell immediately to the east. Minus 1 plus 1 refers to the cell immediately to the southwest. And there's also a notation here that allows you to refer to a cell that doesn't exist yet, plus plus. For relationships other than containment, cells can be bound together in triples called triads. And this is also where the name Thyrd comes from, because we bind cells together in threes. The three corners of a triad are called A, B, and Y. They're represented as 3 paths into third space. But I like to think of it as a directed labeled graph, where A is the head, B is the tail, and Y is the label. So this entire network of triads is essentially a directed labeled graph where the labels can participate as nodes in the graph. When viewing a cell, we can choose to show the triads. And this cell has one triad, and these are the other 2 corners of the triad that is attached to it. Each of those are portals to navigate to those cells. So in summary, a cell is a location for a mutable value in third space. It specifies its type and its relationship to other values.